Okay, so today's lesson we continue on with volume. We're looking at volume of a pyramid, and that's actually on your reference sheet. So if you have your reference sheet out, or you can get your reference sheet out, that formula is 1/3 big BH, and big B, obviously we've been talking about that, is the area of the base of your pyramid. And that doesn't always have to be, it's not like always, we talked about this also, it's not always an Egyptian pyramid type base with a square base. It could be a triangular base, it could be octagonal, right? There's different types of pyramids, although the most typical one is going to be the one you're used to seeing. Alright, and reminder, this is on your reference sheet. It's not one you need to remember, you just need to remember how to do it. Alright, so first problem. The pyramid is an arena in Memphis. The area of the base of the pyramid is about 300,000 feet squared. Its height is 321 feet. What is the volume of the pyramid? Okay, well, so as soon as we see the pyramid, we know we've got our formula, 1/3 big B H. And they actually tell us big B in this one, right? Don't they? The 300,000 feet squared is actually the area of the base, so there's nothing to calculate there. And they give us the height, so we're set. So volume equals 1/3 times 300,000 times 321. Go to your calculator. And fraction key. Third times 300,000 times 321 and 32,100,000. Okay. And we talked about the units, that would be feet cubed. Finally. So that's very straightforward. Nothing to even figure out there. Very basic, know your formula, plug it in. Alright, same idea here. On volume of the pyramid, you should recognize it as a pyramid. Volume equals 1/3 big BH. This time they don't give us big B. So, but we know our base, it looks like it's a square. So base times height, length times width, size squared, whatever you want. And your base and your height are 10 by 10. So the area of the base, 100 inches squared. Alright, and then we bring it back over, so volume equals 1/3, big B is 100, oh, the height. Okay, so is the height 13? No, the height's not 13, 13 is the slant height. Don't get confused with what we used when we did surface area, right? That would be the height of the triangle. We need the height of the entire pyramid. Alright, so I can hear you. You're saying Pythagorean theorem. So a squared plus b squared equals c squared. C would be 13 squared. B would be 5 squared, or a, however you want to do it. So a squared is equal to 13 squared, 169. I got 169 minus 25. 144. So A is equal to 12, or your height is 12, which means your volume, you type all of that in, and you should get 400 inches cubed. Final answer. Alright, so that is a quick view of volume of a pyramid. So you can add that to your repertoire. And then now we're looking at volume of a cone, which again is also given to you on your reference sheet. It is given to you as 1/3 pi r squared h. However, if you think about it, volume of a cone, the bottom of the cone is really a circle. Base of cone is a circle. So big B would be pi r squared. So really, it's no different than the other one here. It is the same. It is 1/3 big B h, right? But this formula, the 1/3 pi r squared, is the one they're going to give you on your reference sheet. So this is what they're going to give you on your reference sheet. All right, so an ice cream cone has 7 centimeters tall. And 4 inches in diameter, or centimeters, sorry, in diameter. About how much ice cream can fit entirely inside the cone, find the volume to the nearest whole number. All right, so again, we'll use the one from the reference sheet. Volume equals 1/3 pi r squared h. So volume equals 1/3 pi. My r would be 2 because my diameter is 4. So r would be 2 squared, and the height of my cone is 7. All right, so I know we're gonna round this, but I'm gonna get it in exact terms first. So I'd be putting in my calculator 1/3 times 4 times 7, or 1/3, that would be 28 times 28 pi. So the volume is really 28/3 pi to be exact, but they did tell you to put that in your calculator and get a rounded answer. So if you type that in, you should get 29 centimeters cubed. You guys check that, make sure that's okay. That's what you should be getting in your calculator. All right, fourth one. Again, find the volume of a cone. And this time you're going to leave it in terms of pi, which we basically did on the last one. So same idea. So we have volume equals, and I'll use the one again on the reference sheet. So 1/3 pi r squared h. But if you want to use big B and h, we can do that also. All right, so what do I need? I need r, but I don't know r. But I know the height. The height is 15, okay? And I can find r, the radius, right, by doing what? By doing Pythagorean theorem again. Okay, so a squared plus b squared equals c squared, or 15 squared plus b squared equals 17 squared. And I know if I subtract and bring over, that b squared is going to give me 64. So b is 8. So my radius is 8. All right, then I'm ready. I got every piece I need, right? So volume equals 1/3 pi 8 squared times my height, which is 15, or volume equals 1/3 64 times 15 divided by 3. I'll leave it like this. Let's see. Pi times 64 times 15. So I'm going to put in my calculator 64 times 15 divided by 3, or multiplied by 1/3. And that should give me 320 pi meters cubed. That should be my final answer for that one. Alright. So, what's different about this one? The volume, they give you the volume of the cone, right? So, if the height of the cone is 8 centimeters, okay, so here we are, height of cone 8 centimeters, find the diameter. They want us to find the diameter of the cone, so we don't know the radius. Alright, so let's see. Volume equals 1/3 pi r squared h. So they give me the volume. So the volume is 96 pi, and I got 1/3 pi, don't know r. If I knew that, I would be all set. Pi r squared, and I know my height is 8. All right, so I've got a 1/3 over here. So if I multiply both sides by 3, or in other words, I could write it like this, if that helps. Pi r squared times 8 all over 3 is the same thing as times 1/3. If I cross multiply here, so I want 96 times 3, 288. So 288 pi is equal to pi r squared times 8. Divide by 8 pi on both sides. Pi's are going to cancel. So I got E 288 divided by 8. 36. So 36, i's cancel, e's cancel. R squared equals 36. Okay, well there's two answers, there's 6 and there's negative 6, but clearly negative 6 doesn't make sense because it's a radius. So my radius would be 6. And units would be centimeters. Oh, sorry, not what we're looking for. Radius is 6, but they actually asked us for what? They asked us to find the diameter. So my radius is 6 centimeters, which makes my diameter 12 centimeters. Final answer, 12 centimeters. All right, so hopefully we're okay on this. This is pretty basic, plugging in for formulas based off what they're giving you. Now, this one's a little bit more thinking, and they've been throwing these on the regions. So, truncated cone. Let's understand what a truncated cone is. You have a basic cone, which you know what it looks like. Here's my basic cone. All right, here's the cone. And here is, we have a truncated cone. And a truncated cone is when you take off a piece of the top and you cut it so that it's parallel to the base, right? That's all your info up here. So when the top, narrower portion of the cone is removed such that the base of the removed portion is parallel to the existing base, the resulting shape is a truncated cone. So this would be your truncated cone. The top piece or cone was removed. Okay, so understanding what's going on there. What is the shape of? What is the shape of the removed portion? Well, we just said that. The shape of the removed portion, the piece that we got rid of to form the truncated cone, is a cone. Okay? So, here's the original cone right here. And then this top piece is the part that we are removing, leaving the bottom, which is your truncated cone. So, do you think the right triangles shown in the diagram are similar to each other? All right, we did similar, so right triangles. Here's one right triangle in blue. And here's the other right triangle in blue. And hopefully what you're thinking is similar triangles, similar triangles. One way to get similar triangles is angle, angle, right? And they both have a right angle. So they each share that in common. And if you look at the top, don't they share an angle? So they share a reflexive angle at the top, which says, yes, they are similar. All right, that's great, but how does that help us? Okay, how does that help us? So, let's flip over, think a little bit more. What does that mean about the lengths of the legs and the hypotenuse? Well, we know if triangles are similar, then corresponding sides are in proportion. So we know that the side lengths are going to be in proportion. And so we want to use all this info to help us find the volume of a truncated cone. All right, so here's our example. Got a lot going on here, so pay attention. It's the last piece. All right, so we want to find the volume of this shape right here given to us. Okay, we don't have a direct formula for that. But can you envision if I put the cone back on top? Right? I want to try to find the volume of this entire original shape. Find volume of original cone. Because if I can find the volume of the original cone, right, and then I can find the volume of the cone that I took off, can't I subtract to get the volume of the truncated cone? So if I find the volume of the original cone, and subtract the volume of the removed cone I get the volume of the truncated cone. All right, so we have a plan. This is our plan. Okay, so I need to, in order to find volume of original, I know that volume is equal to 1/3 pi r squared h. Okay, and so I know what the radius is. The radius is 12. So volume equals 1/3 pi 12 squared. What I don't know is the height of this whole thing, right? Nor do I know the height of just the smaller piece that I got rid of. That's what I need to find. All right, so how does the stuff that we talked about before going to help us? The similar triangles are going to help us here, right? Because we can relate that the smaller triangle, right triangle up here, is similar to this bigger one. And you can see that one of the sides of the smaller one is what I need. That's the missing piece I need, so call it x. All right, so then I know that the sides should be in proportion. All right, so I'll do that down here. Sides are in proportion. Well, this is the reflexive angle, so the side opposite the reflexive angles are in the same proportion. So 6 is to 12 as, match up the 6 and the smaller with x. And now, what is the actual side of the whole entire big triangle? Well, it's really x plus 4. So x over x plus 4. And then what do? I cross multiply. Right, so I've got 6 times x plus 4 equals 12x. I can divide by 6 or distribute. You guys would probably distribute. So 6x plus 24 equals 12x. We still have room here. A little bit. All right, subtract the 6x. 24 equals 6x, which means x is actually 4. All right, well that just opened up everything for me. I'm ready to go now. So I know that the height of the original, or big one, big cone, okay, the height of the original or the big cone is now 8. That whole length. Okay, so my volume, I'm doing 144 times 8 divided by 3. 144 times 8, enter, divide by 3, because it's multiplied by a third. Nope, where am I missing? Oh, too many 4. 144 times 8, enter, divide by 3, enter. I'm getting 384 pi. So volume is 384 pi centimeters cubed. And now, that's too much. That's more than what I want. So I need to figure out the volume of the cone we removed. Removed cone. All right, so the removed cone, still the same formula, volume equals 1/3 pi r squared h. So volume equals 1/3 pi. Radius of the removed cone is 6. So 6 squared, and we already know the height. The height is 4. That's what we found when we did that other proportion. So the height is 4. Plug my numbers in. So I've got 36 times 4 divided by 3. 36 times 4 divided by 3. So it looks like 48 pi for the smaller cone that I removed. Centimeters cubed. All right, so truncated cone, volume of truncated cone is going to equal, biggest one, 384 pi minus 48 pi. minus 48, 336 pi. 336 pi centimeters cubed. And go back and read, what do they want here? They asked me to round, just determine the volume, no rounding. Okay, then I'm done. That is the volume of my truncated cone. All right, so you have your lesson. Okay, so now you have, as an assignment on the board, geometry. So add that to your list. You got to work, obviously. You got the problem down here below. You also have some problems in the book to work on. Okay, and you have some regions, which is on the board in front of you. August 2016, 15 through 19, 27 through 30, 32, and 33 to complete. You have the rest of the period to work on this stuff. So I would start on the regions. I know that the second class, period 6, already did a couple of those regions ones. They're a little bit ahead of period 4, so make sure we get caught up and have a great weekend. I will see you on Tuesday.